Okay, so the molecular formula for butene is C4H8, which is the empirical formula. Remember, the empirical formula is the simplest ratio. So if I've got C4H8, I can divide that by 2, and that'll get me C2H4. But I can still simplify that further, and that'll become C1, don't put the 1 down, H2. So the answer to that one is B, is the empirical formula, the simplest ratio. Calculate the relative formula mass. So what we do here is we have got 4 lots of carbon and we have got 8 lots of hydrogen in the formula. Carbon's got a mass of 12. We're told here the relative atomic mass, and the relative mass for hydrogen is 1, so let's put information in. Hydrogen is 1. Okay, so that's going to be 4 times 12 is 48. 8 times 1 is 8. Add those two together, and that's going to give me a final answer of 56. When burnt completely in air, butane forms carbon dioxide and water. Complete the equation for this reaction by putting the numbers in the spaces provided. So our method to work this out, I'll do it above. Okay, there are 4 carbons on this side, and there are 8 hydrogens. There are 12 oxygens. Now remember, 12 oxygens because you've got 6 times by 2 is 12 in total. This side has to be the same. So C, H and O. So at the moment there is 1 carbon, there are 2 hydrogens, and there are 3 oxygens. So I have to try and get these numbers to become the same as these by balancing the equation out. So how am I going to get 4 carbons? Well, I could, and let's test it out, put a 4 in front of here. So that gives me 4 carbons. That will give me 8 of these, and plus 1 here is 9 oxygens at the moment, which is still not quite right. I've got to get 8 hydrogens. I've only got 2 here, so let's put a 4 in front of here. So that does give me 8 of those. Now we can add up the oxygens again. So I've got 4 times 2 is 8, and then this side I've got 4 times there, so that's another 4, that's 12, which is a balanced equation. Describe the test for carbon dioxide. This is where we bubble the gas through lime water, and the lime water will turn cloudy. Okay, so bubble the gas through lime water and the lime water will turn cloudy. It is a positive test. Okay, last couple of questions on this one. This substance is a gas at room temperature. It's a simple molecular covalent substance. That means it's going to have a low boiling point, melting point. Which row indicates the property? So I know straight away it's going to have a low boiling point, so it can't be that one, that's too high, and it can't be that one. The only difference between these next two is they both have a low one, but solubility is low and solubility is high. Simple covalent substances are not good at dissolving in water, so therefore the answer to this one is A. Next question, diamond and graphite has a giant covalent structure. State one property of diamond that is a result of this giant structure. So we could say, there's a list of things we could do. We could say it's got a high melting boiling point. So high melting boiling point. We could say that it does not conduct electricity. Okay, so it doesn't conduct electricity. We could say it is insoluble in water. You don't have to put one in, but they would be good answers to include.